Filho? He's going to tell you how to correctly pronounce his name because I did a terrible job. From University of Sao Paulo, Brazil, so he's traveled a long distance to tell us about fruits and vegetables.
Good afternoon. My name is José Caixeta. We pronounce X as your SH. I am a full professor at the University of São Paulo, Brazil, where I'm also the coordinator of this research and extension group in agricultural logistics. The idea is to talk about losses, physical losses, in the transportation. So we cut very clearly this part of the supply chain, and giving some examples, some thoughts on the transportation of fruits and vegetables, and the use that we have done of a mathematical model, optimization mathematical model, to help this case study. The structure of the presentation, we have an introduction, then the methods, the mathematical structure that we define, the results, conclusions, and the reference. The first thing, for Brazil, we have seen a lot of applications to transportation problems. Perhaps there is a predominance of transportation of passengers. In the last 10 to 15 years, we have more examples of transportation models for cargoes, and among the cargoes, a lot of agricultural types of products. And for this type of business, agriculture, the representativeness of the freight value is very high in Brazil, especially because we produce most of the case raw material, and raw material normally have low added value. And besides that, we are used to get a lot of transportation using what we call highways. So the highway freight is for sure higher than the railway freight, that's higher than the waterway freight. So the road transport, the highway transport is very representative in Brazil. From what we have seen, the Brazilian situation in terms of losses, physical losses, is not different from the other developing or less developed countries. We have a magical number of something around 30%. Some people say that's a guess estimate. But out of those 30%, perhaps 10% relate to transportation. And perhaps because we have, as some other countries, very different types of regions, very different types of sources, very different causes, several different types of methodologies. So the objective of this paper, that unfortunately I think it's not printed in the material that you receive. They say that they are going to put the file in the website, is to revisit this model that we developed some time ago, and to discuss the potential for its replication to other situations, and who knows, to other agricultural type of products. So, the first very important thing, we have no doubts that the losses happen during the transportation. And as modelers, we try to simplify the reality to transform this into a model. So when we talk about transportation, we select three main factors. One is the type of vehicle. The type of vehicle to move agricultural type of cargoes can make a difference for the level of the physical loss. The other factor is the condition of the road. Depending on the condition, depending on the type of the pavement, you can have bigger or lower physical losses. And the other problem related to transportation is the packaging pattern. Depending on the position of the packaging, depending in the type on the type of the packaging pattern, depending on the piling of this set of packages, depending on the existence or not of packaging. Here you can see some pineapples without any type of packages. For sure, the level of losses can be totally different. And as mentioned for some of the presenters, we have no doubt that physical losses are directly related to poverty. We still have in our country a lot of people that consume those physical losses. And that's a big problem. Perhaps the most important problem to be solved is the poverty. But because of that, you have a market for this type of leftovers. And here are some examples in some market fairs in Brazil. So, in view of that, we define a mathematical model, including all of those considerations. And the model itself required behavioral functions, supply and demand functions, transportation costs, loss functions, and the distance between the regions. And those distances were correct according to the type of the road, the condition of the road. The case study was related to trade of pineapples and tomatoes. And we used the GAMS as the language modeling to input and process such a model. So I'm not going into the detail of the mathematical structure, but basically it's a normal transportation model, the objective function, cost of the wholesalers to be minimized, subject to supply and demand functions. And in all of those mathematical expressions, we consider the difference between the packaging patterns, the difference between the types of vehicles, and so on. The results that we got from the model were interesting. They were good to help the decision makers, especially the public actors, the public agents, to write, to define their policies. And we don't have big surprise in terms of the results. In the case of fruits and vegetables, we need good roads, such as those. We need good vehicles. In this case, that's a refrigerated vehicle, a refrigerated truck, using good pattern of packaging, in the case plastic boxes. So the model helped to validate what someone could reasonably find as a technology to help to minimize this type of losses. But the same model can be useful for some other dreams. Yeah? Here, one of those, why not to move in that manner agricultural products? Another one, that's a watermelon, and that's real. That's a new packaging pattern. That's a round watermelon. So perhaps this is much more difficult than the previous type of things, but it's possible to help someone to decide about those. But the main problem is related to this picture. Who is carrying the main effort is the farmer. And normally, the farmer doesn't want to pay the extra money that's needed for minimizing those losses. And in Brazil, and I know in a lot of countries, this happens. Usually, there is a very big dependence on the willingness to pay from those farmers in terms of accepting a new technology, in the case, a new packaging pattern, to avoid physical losses. So, the model has plenty of conditions to be adapted to other situations, segments, and agricultural products. The initiative of Wageningen is very much welcome because we have clearly a lack of systematic collection of this type of data. And in that regard, we are just initiating 2 new projects in Brazil using a similar type of model. The first one related to physical losses of grains along the whole supply chain. And we should cover 80% of the production of grains in Brazil. Here, there are grains, but you can imagine that this could be sugar as well. We are also starting a new project to measure the physical losses of sugar along the whole supply chain. And that's interesting because, as someone already told, we are seeing a revival of this type of thing. A lot of people here have worked with losses some time ago. And then suddenly everyone wants to work with this again. So we are here. But in the case, it's interesting because the incentive to run those 2 big projects in Brazil is related to taxes. So the government measure the weight of grains or the weight of sugar after the farm gate. And from the farm gate, for instance, to the port, there is a lot of physical losses. So the government accepts a minimum of 1% of physical losses from the farm gate to the port. So the idea of this project is also to help the measurement of those physical losses, and who knows if this can bring some impact, some new policy in terms of taxation. Okay? Those are the references that are mentioned in the presentation, and thank you very much.
Do we have any questions? Is there?
Hi, my name is Yogendra Shastri. I'm from India. Actually, I have a question related to the last point you made, that you said that it may lead to some policy changes. And I do similar kind of work, and we end up publishing papers. And the next question I have is how do I make sure that this translates into a policy? So do you have any thoughts on how we can push this ahead and how to market it to policymakers that this kind of research eventually becomes useful?
If I understood correctly, I'll give you some examples. In the case of tomato, usually the tomato comes from the farm to the wholesale market, okay? And the wholesaler assumes that the physical loss is done and the level is 30%. So the wholesaler accepts already 30% of physical losses. And this figure is discounted from the payment to be done to the farmer. So the market reacts such as that. Who has the bigger bargaining power doesn't pay for the physical losses. Another important thing, we see a lot of physical losses in the transportation activity. This doesn't mean that the physical loss was compulsorily generated during the transportation activity. Sometimes you can get a reasoning, I don't know, in the pre-harvest type of operation. Or in the same sense, during the transportation, something could happen that doesn't show up during the transportation itself. It shows up only, I don't know, at the shelf of the supermarket and so on. Okay.
Thank you.
Thank you.
Yes?
I forgot. We have here in the first row some institutional material. If someone wants to get, please take the folder from the first row.
Thank you. It's my pleasure to